Hi everybody. So in this video, we're going to look at solving a system of equations using matrices. We'll begin with two unknowns, and then we'll look at a system of equations with three unknowns. And to find the inverse matrix, we're going to use a calculator. Okay, so in this example, we've been asked to solve this pair of simultaneous equations using matrices. So if we begin by creating our matrix equation, this involves extracting the coefficients of x and y, so the 3, -2, 5 and the -3, as one 2 by 2 matrix. So this becomes 3, -2, 5 and -3, and then we multiply this matrix by x and y, and this will give us 5, 9. So now we need to say let A equal the 2 by 2 matrix of 3, 5, -2 and -3. So what we have done is this matrix multiplied by xy to give us 5 and 9. And if we multiply both sides of this matrix equation by the inverse of matrix A, you can see that these two will cancel. So what we're left with is xy will equal the inverse of matrix A multiplied by 5, 9. And we can work out the inverse of this matrix using a calculator. So if we go to our calculators, we press menu and then option 4 for matrix mode. We need to define matrix A, so we'll choose option 1. And this is a 2 by 2 matrix, so 2 rows and 2 columns. We'll enter matrix A as 3, -2, 5 and -3. And we'll input this matrix with 5, 9 as matrix B. So we'll go out to option. We want to define matrix B, so option 2. This has 2 rows and 1 column. The elements are 5 and 9. So then we go to option. We want option 3 for matrix calculations. What we'll say is that xy will equal the inverse of matrix A multiplied by matrix B. So we'll press option, we'll choose matrix A, we'll inverse that by pressing the reciprocal button, and then we'll multiply this by option 4, matrix B. And you can see that the x value is equal to 3 and the y value is equal to 2. Okay? So this is how you solve a pair of simultaneous equations using matrix methods. So now I want to show you another example for a pair of equations that cannot be solved. So now we've been asked to use matrices to show that this pair of simultaneous equations has no unique solution. So we'll go through the same process. We'll set up our matrix equation using the coefficients of the x and y's. So we've got 1, 2, -2 and -4 multiplied by xy will equal 3, 6. We'll let A equal the 2 by 2 matrix, 1, 2, -2, -4. So we have A multiplied by xy will equal 3, 6. Then to work out xy, we need the inverse of matrix A. Because then these two will cancel, and we're left with xy will equal the inverse of matrix A multiplied by 3, 6. So this is all good so far, but what if this matrix A has no inverse? Well, if it has no inverse, then this doesn't exist. So there'll be no unique solutions to this system. If you remember from a previous video, only when the determinant of a matrix does not equal 0 does it have an inverse. So if the determinant of matrix A equals 0, then this is a singular matrix, which means it has no inverse. So to show it has no unique solutions, we need to find the determinant of this 2 by 2 matrix. So the determinant of A will equal the 1 times the negative 4 minus the 2 times the negative 2. So plus 4. And this does have a determinant of 0. So because this is a singular matrix, it has no inverse, which means we can't solve this system of equations. Okay? In the next question, we're going to solve a system of equations with 3 unknowns. So now we've been asked to use matrices to find the solution to this system of equations. So the idea is exactly the same. We set up our matrix equation using these coefficients. So we'll have 1, 2, 5, which are these values here. 1, minus 3, and 2. Negative 2, 5, and 1. Multiplied by x, y, and z will equal 3, 4, and negative 3. We'll say let A equal this matrix. So now we have A multiplied by x, y, and z will equal 3, 4, and minus 3. So we'll take the inverse of matrix A to both sides. So x, y, and z will equal the inverse of matrix A multiplied by 3, 4, negative 3. So on our calculators, we'll let this one equal matrix A, and we'll let this one equal matrix B. So we'll go back to our calculator, menu, and option 4. We want to define a matrix. This time it has 3 rows and 3 columns. We'll input our elements of 1, 1, negative 2, 2, negative 3, and 5, 5, 2, and 1. We'll go to option, we'll define matrix B. So we'll choose option 2. This has 3 rows and 1 column with the elements of 3, 4, and negative 3. So then we'll go back to option. We'll choose option 3 for matrix calculations. We want matrix A, so option 3, inversed, multiplied by matrix B, so option 4. And this will give us x will equal 2, y will equal negative 5, and z will equal negative 3. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com.